Alright, so what we're going to be doing today? Shh, no talking now. Got to learn to focus. Alright, the big one is, and even a lot of teachers have this saying that physics is really, really difficult. Is it recording? Yep. That physics is really, really, really difficult. It's not. It just takes a lot of hard work, and that's what you've really got to get into your head. If you're willing to put that work in, you'll do absolutely fine. So let's do the roll quickly and then we'll get going. Joe? Yeah. No, Jordan, Josh? Yeah. Elijah? Yeah. Lachlan? Yeah. Lachlan Clifford? Yeah. Michael? Yeah. Annalise? Yeah. Colby? Yeah. Rowan? Yeah. Grace? Yeah. Kerry? Yeah. Hayden? Yeah. Lachlan? Yeah. Gordon Campbell? Yeah. Trayson? Yeah. Alex? Yeah. Shelby? Yeah. Ariane? Yeah. Talia, yeah. Finn, yeah. Joshua, yeah. Josh, Mikkel, yeah. Maxim, yeah. Hugo, yeah. Alex. Yeah. Have I missed anybody? Cool. Right. So what we're going to do is this is going to be done at a rate of knots. Now the reason why I'm doing it fast is if I go slow because it's an afternoon, you'll get bored. And what happens when you get bored? Yeah, you switch off. So I've got this really thing. I'm just going to go so fast you're not going to have a chance to get bored. You're going to be, what's going on? That's why I'm recording it. Because another thing, what happens, and I know a lot of you are doing this now, when you start trying really hard, something amazing happens. You then realise there's a lot of stuff you don't know. That's a good thing. It means you're trying harder. Don't get into the panic, because when you don't try, your brain doesn't know anything, and it's happily just going on in ignorant bliss. You're going to all focus today, and so afterwards you might feel a little bit freaked out because you're not in ignorant bliss anymore. You are basically welcome to the world of Year 11, and that's absolutely amazing. What I want you to do, not until the end, and you can even do this maybe about 2 hours after the end of the class. This is an extra section. WIAA. Now I'm not going to tell you what that stands for. You can look at the form not yet, you can look at the form later, and I want you to do that. Okay? Right. We are going to look at the student experiment. So I've added a few goodies for you because a lot of you spoke to me during tutoring and just came to chat to me. So I know what bits you know and what bits you don't know. Firstly, realise the reason why we're doing the experiments at different times is because if you do lots and lots of science, is that working okay? Doing lots and lots of science, you don't have everything happening together. I know it's going to be quite busy. So there's no advantage nor disadvantage. If you do lots of science, yes, you're going to be busy, but it means you're going to know more of how to do a research question, more of how to write it up. There are differences between physics and other topics. That's why I want to go through with you. Went through this last time. You've got your task sheets. You've got a choice of heating, ionizing radiation, electrical circuits. After looking, I'm just going to say you've got two choices, heating and electrical circuits, unless you can really convince me. Because a few of you are bouncing off research questions for the others, they're just too complicated and you're not going to get anywhere with them. By the way, I've got some examples. Is it working okay? I've got some examples of these research questions, and I'll go through those very, very soon. Questions? Nope. Okay, I'm obviously not going fast enough because some people are having a chat. Let's go even faster. You've got your draft checklist. Your draft is due week 6. When in week 6? Wednesday. And I will want it at 8:20. Good. 8:20. You beat me. Hello, Steve speaking. No, he's down in his absence. Yeah. Okay. Thanks, sir. Bye. Sorry.
How do you complete all the experiments?
Sorry? Oh, we have. Yeah, we have. But you need to modify them. The ones you did for the earlier ones were. Let's just make sure it's not working for some reason. Why is it not working? There we go. These are the ones you complete. You completed those ones with Mr. Gill. I double checked. And the one we haven't quite finished. How is Steve speaking? Michael, yeah, okay. Right. Michael, can you go and see Mr. Fernandez, please? Yeah, so there's a couple of the later non-mandatory electrical ones that we haven't done, but they're non-mandatory.
I can't remember if you
Yeah, and we'll go through it. So don't worry if you don't remember, stay back after school and I'll go through it with you. Okay? Yeah, no worries. This is going to, by the way, this will involve more of your time because you know that I'm not a mind reader. I won't know what ones you've done and not, well, actually I do know which ones you've done and I've done with Mr. Gill, I asked him. But I need to know which ones you remembered. It's all right doing them, but you need to remember doing them. You need to all be on task, guys, so you need to be listening. I'm going to go even faster if you're not listening. So we're going to do heating or electrical circuits, unless you can really, really, really convince me. Your draft is due in 2 Wednesdays' time, week 6 at 8:20. Just to give you an idea, I've done this in other states, and we've given people 4 days to do something like this, and they've done a really good job. I've seen people even do it in 2 days. We used to call it the FedEx Challenge. We stopped doing it because people stopped sleeping and we've got very competitive. Experiments can be done very, very fast. I don't want you to overthink this. I want the draft to be written up naturally with my help, because the more you put down, the more feedback I can give you. If you spend, like James Joyce did with Ulysses, if you spend like a day thinking of every sentence, are you going to finish it? No. I can do a lot more with you if you just write loads and loads and loads down. Like I say, you don't need that, you need that, you don't need that, etc., etc., etc. This is a practice one, remember. This is getting you ready for the real one. If we feel we need another one, we can do another one. It's not a big deal. It really isn't. Your draft checklist. You've probably learned this from other teachers as well. The draft is not a massive, massive thing. Most of your feedback is going to be gleaned through what? Not through that, through what? Class time. Through class. And what else? Not just class time. Tutoring outside of class time, yeah? And I'm here to help you. You've all got different learning needs. A couple of you said, I'm not very good at English. You don't have to be good at English to do this. You have to use very simplistic English. In fact, it can possibly be a disadvantage to be too good at English, because some of you use too fancy language. You can't use emotive language because it doesn't mean anything. Like I had one last year. It was horrendous. I don't want to know about your emotions. I just want it to be done, because those kind of things will detract from a really, really, really good student experiment. Okay? Again, another couple of panics. You were looking at this experiment, you said, why have you given us this? This is nothing to do with what we're doing. I know it isn't. This is a research question. It's an exemplar. It's on throwing something. It's just to show you what titles you need. And then a couple of you didn't realise that. So I want to do the same thing as that, as projectiles. You can't, because I'm not going to let you. All right? Actually, I could let you, and you might find that other teachers from other schools might say, oh, you can do it on any topic you want. I want to focus on the topics you've done. It really does help you, okay? So this is just giving you an idea of how it's written, and hopefully not to scare you too much, because it's nowhere near as bad as it sounds. It's putting things together, and I will pick things apart today about it. For example, the management of risk. I've seen your ones from year 9. You can do a better job than that from your year 9 ones, because what do we use at this school when we're doing management of risk? What program do we use? Risk Assess. Just by using Risk Assess and doing a good job with that, that's better than they've done. Okay? So it's just for you to look through. Your table doesn't have to look so schmick as that. It needs to convey information. In fact, that looks good, but it doesn't convey probably information it should do if we look at it. But don't worry, you haven't got to understand what they're doing. You just got to understand how they show it. Because why do we have a table, basically? Why is that there? Show data. Nicely, isn't it? Instead of just there. Yeah, it doesn't. You don't want to be like you've sicked up a bit of data and I've got to sort it out. And that's what happens with a 20 out of 20 student experiment. It will take me hardly any time to decide it's 20 out of 20, because they convey the information so clearly. Okay? I'll be showing you today how to draw the graphs, so don't worry, we'll try not to have complicated graphs like that. We'll try to have simpler ones. The simpler the graphs, the better in physics. If your graphs are getting uber complicated, it probably means your research question is uber complicated. We'll talk about that a bit later. Okay, and then you give your evidence, and then you evaluate, which we'll go through as well. Improve. Always have improvements. There's always going to be improvements. If you've created the best experiment ever, you probably should go off and work for NASA instead of being in year 11. And then a very, very brief conclusion. Actually, it can be shorter than that, because the conclusion can be marked throughout the rest of it. The great thing about this, you don't have to put every single title down. I think most of you will, because you feel better about it. But I can mark anywhere. It's called a positive marking scheme. I will look for your information, and I'll always mark from the top down. I'll be looking for evidence of the top thing. I won't want to move you down. Okay, and then a reference list. Different teachers have different rules. Mine's very simple. You just use Harvard. Harvard Anglia you'll use, yeah? I know you might use APA possibly for psychology, do you? Yeah, just get used to using different ones. It's good to use different ones. Okay. Yeah.
Why is it called Harvard?
Because Harvard actually decided. So what used to happen is people just used to write references. They used to write, I read this book from blah blah. And then the Psychological Association, APA, they decided, let's make this more consistent. And Harvard decided, everyone just uses their ones because they're simple. There was loads out there. They're the simplest one. Focus, guys, thank you. So I've given you that. You don't have to use this. This is just giving you an idea how you can set it out. When I was your age, we just had a beginning, a middle, and an end. It was that simple. That's what it is, really. All right, they've plugged a few things in. Today, we're going to look at Excel graphing. So I've spent loads of time doing this to save you doing it. That's why I'm recording it as well. Because if you watch the videos on this, it can be really long-winded and quite boring, let's be honest. So thank you to, I think it was your group. I grabbed some data off one group and I've added a couple of little things in, so it's not exactly like your data. The reason why I got their data is because they do theirs on their OneNote. It's a useful thing to do it on your OneNote, because if your computer goes missing, which unfortunately it could do, you've then got it backed up. Yeah, of course we've got one. Yeah, unfortunately. It doesn't happen very often. Or your computer can break. I had a year 12 last year go like this. Just give me his draft, throw it there, and the computer went, whoop, straight off, smashed. We had to, and it had to be in, so we had to get the hard drive out of it. So things will happen. If you do it on OneNote, it will back it up. Or on Teams, it will back it up. So it's very useful. So thank you for your data. I have added things to it. This is, I've been looking at lots of them. There's no perfect way of learning this. I prefer to follow videos in physics to do it. So this has got both though. So if you click on that, you don't have to yet if you don't want to. This will take you to this menu, and this is a university. I can't remember which university it was. And they show you how to add experimental data, blah, blah, blah. But these are the three things I'm going to show you today. You don't need the other bits. You just need a really decent graph to convey information. So what we've got different examples. So I'm going to go through this uncertainty example. You're welcome, and in fact I would actively encourage you to open up this example Excel, and follow along. Because what's going to happen in a few months' time, you're going to get a really amazing guy called Dr. G, who's from UQ, and he's going to come in and show you a lot of this. He just a broad scientific research idea. And what I noticed last time, teachers and students included, the people who just watched, about a week later, they've completely forgotten, me included, because I like to do the role. And what happened to the people who did it along with him? They retained it, so I had to get people to help me to do it afterwards. Yep.
So, you know, in the OneNote,
Yep.
is it the one to the right or is it the top link?
Show me again. Which one? On here, you mean?
Yeah.
This one.
Yeah.
Yeah, this one. So I would follow along if I was you. Some people have a little chitty chat, which is rude and not the right thing to do in any case. Guys, thank you. Shush. You need to concentrate, else you can come up and do it. All right, so let me show you. So what I've done, I've grabbed analysts group. Who's in your group? These guys, yes, so I grabbed your data. I added a couple of things on purpose. It's not going to be exactly the same as yours. Just I used it as a starter. So what you got here is, and yours will be different. And don't think, oh, I'm going to do mine on circuits because it's the last thing we did. A lot of the other group last year, and I'll actually show you a few examples of what they did last year, did electricity. But Ethan was talking to Shelby, wasn't he, on Friday, was it? It was both of you, yeah. And he said that what the pros of it was he'd just done it. What was the cons of it?
It wasn't like a great testimony.
Yeah, he really hadn't understood what he was doing. I've gone a lot faster with you guys, which I know has panicked a few of you. But the reason why I went a lot faster was that feedback from Mr. Gill to say, get as much electricity done as possible. So if they do decide to do that experiment, you know what you're doing. Yeah, but realise electricity is complicated, you will need help. So we've got this. Always put as much information as possible. And a lot of other subjects won't do this. That's where physics disagrees with a lot of other sciences, because it's very easy to collect data in physics. If you can put a voltmeter in there or put a thermometer in there, even if you're not thinking of using it, put it in. Because when it comes to modifying the experiment, you don't have to redo the experiment then, do you? It's a lot easier. If you can do experiments in one go, good. Because as soon as you start redoing the experiment another day, what could happen and what does happen? You've seen this in chemistry and other subjects. It doesn't work. Why doesn't it work? You're right, it just doesn't work. But what are the reasons why it doesn't work?
Because you've changed something, you just don't quite know what
Yeah, and we talk and talk and talk. You've talked into in year 7 about control variables, but we can't control everything, can we? Like today, I can feel it's a lot colder in here than it was a couple of days ago. That makes a big difference if you're doing a heating experiment. Really amazing amount of difference, crazy. So the easiest thing to do in physics, which you don't get in other sciences, is just get it done. Prepare, prepare, prepare. Do it. Sort it. Make sure, like, this will be a good time next week. If you have to go over, make sure that you let your parents know, or maybe even say, you know, can you pick me up if you catch the bus, just in case your experiment goes over. It means you can stay afterwards. So plan ahead. And I know a lot of you, oh, I've got to go pick my brother up. Plan ahead and you won't have to. Right, make that. So what I did is I also got this, I think it's got this, I'm not sure if I got this from your group or from another group. I also got the voltage reading they collected. So that's the voltage. What voltage is that? How have I collected that voltage? Yeah, I've got, oh no, that's the voltmeter. What one's this one?
The original.
Yeah, basically on the power pack, isn't it? What do you notice about the voltage and the voltage reading on the voltmeter? It's less. Now, this is when we look at systematic error. This is good, and it's a great thing to talk about because you noticed systematically, approximately, I know you're not going to do calculations quickly in your head, but it's about how many volts less each time. About 0.3, isn't it, each time? That's systematic. That means there's either energy lost in the wires, and you can talk about this, or it might mean that your power pack is just not a very good power pack. Always use the same power pack if you are doing electricity, and always use the same heat pack if you're doing the heating one, because if you swap it, it will be different. You know what I mean? Even look at the sticker, look at the serial number. That works. Writing that kind of stuff in your method is spot on, because when you're doing a method, it's basically like cooking a steak. All that information must be there so you can give it to anybody else, and what should they be able to do with your experiment?
Recreate it.
Yeah, replicate it. And that's simple as, I know a lot of you have moved from different countries and different states. It doesn't matter what words we use in Queensland, it's so we can replicate it. If you make your write-up so that somebody can replicate your experiment, that is a good student experiment. Okay? Then we've got the trials. Can you just go through, Michael, what did you do for your trials? Did you do all the first trials first? 2, 4, 6, 8? Yeah, so they did 2, 4, 6, 8 first, then they stopped, then you did 2. That's the best thing to do. So you do it straight away, of course, you can get exactly the same numbers. You want to make it so they're different. Any guesses why you think they were different on this one? Any ideas? What could have happened?
As you turn the power back on, it's probably generating heat.
Yes, there's heat in the power pack, and that can actually cause more resistance with generated. It could be heat in the wires, could be lots of things, can't it? Doesn't really matter yet, but there's a difference. Now this is what we do. I've created one of these that's already done, but just can you follow along with me though? And if you don't follow, don't worry, that's why we're videoing it as well. And there's a video on that website that I gave you. I can't really do much else. I can even sit with you and do it with you all. Do me a favour though, if you want help with this, can all of your group come in one go? It really winds me up when we get one person and the next person and the next person all throughout one day comes and asks me, because it's not fair on me. So all come together in one go. So current average, to do an average of something, you do equals, average. If you want to do this different, you can. Close brackets, and then I just select them all. C3 to E3. I'll make that a little bit bigger so you can see it. Okay. And then it gives me the average. I then click on it and go to the corner. If you go to the corner, it changes into that little sign there and drag it down. And that copies the average down. And it's not the average of each one. You should also use your brain, because God endowed you with an amazing brain, and look and say, is that about the average? Because you can tell straight away if it's about the average. You know, there's been multi-million-dollar losses in companies because somebody hasn't checked a spreadsheet. When you go home tonight, just Google biggie spreadsheet blunders. Some of them are, I think one of them was 1.1 billion because somebody stuffed up doing something like this. Yeah.
JP Morgan's in a legal case at the moment. They're a big investment bank because someone left out a 0 on the end of a metals table. So they're being investigated for metal spoofing, for buying metals under cost.
Yeah, and that's the trouble as well, because when you do this in the real world, even though it's an accident, you've got, with tax, you've got to prove it's an accident. It's not innocent until proven guilty with tax. It's guilty until proven innocent. Similar stuff with your experiments. If you stuff up with your data is leading. So you can't say something different to what your data is showing me. You understand what I mean? Don't try and con me, I'll see straight through it. It doesn't matter if your data goes down a different idea than your research question. That's not a bad thing, is it? It doesn't matter if your research question is incorrect. It's just how you follow it. In fact, if you find it very quickly, it probably means your experiment is a teeny weeny bit too easy. Then the current error. You might have never done this before. You do equals, brackets, max, brackets. Not that max, this max. So max, brackets. And then that's the maximum of all those three. Minus, this is on the other tab, by the way, if you can't follow me. Min, brackets, all of the same. So it's going to do min minus max, and I'm going to divide by 2. Now you could do that manually if you wanted. Why don't we do it manually? It takes too long. I know a load of my physicists last year still did it manually because I clicked on there. Special fine if you want to do it manually, but you'll make a mistake. So that's showing you current error. Now if you look at current error, you can see again, they are very, very close to each other. So they're actually very far away from each other, so that's going to be quite a big error. Some of these are actually very close to each other, so it's going to be, you might say, well, that's bigger than that. Not really, because it's different relative sizes, it's relative error. And we'll look at that as well. It's relative to the size. And look, even though that's small, what do we know about these readings? And we'll do that a little bit later. They're small as well. It's a relative error. It's like if I make a 10 centimetre mistake when I'm measuring this room, you go, that's fine. But if I made a 10 centimetre mistake when I was measuring my hand, is that fine? No, because relative to what I'm measuring, it's a bigger percentage. Okay, it's a bigger percentage. That's it. Then we're going to have the current max and the current min. Now there's a couple of different ways of doing this.
Hi, Mr. Gill.
There's a couple of different ways of doing this. Focusing on me, guys. I know Mr. Gill's interesting. Thank you. All right. You've got to work out the current max and current min. Now there's actually 4 different ways of doing this which are perfectly correct. I'm going to do it this way just to show you. I'm going to do the average equals the average plus the error to get the max. And what do you think I'm going to do to get the min? Yeah, the average minus. There's other ways you can just actually choose which one's the biggest and choose which one's the least. It's fine. Then I can select both of those and pull down again. Do you want to just close that for me? Thanks a lot. Here you go. Then we've got this information. Cool, isn't it? We've got lots and lots of information. Now, the trouble is, if I even gave that to one of the top physicists, they would just look at it and then walk off because it's not interesting. It's not conveying what I want it to convey because it should be easy to understand, shouldn't it? Let's make it easy to understand. So what we're going to do, we're going to choose the x and y. So this will come a bit more evident in a minute. So I'm going to choose 2 and 12. Now you could even choose 1.7, 11.6 because that was the actual from the voltmeter, but you need to be clear on what you're doing. You need to be very clear on what you're doing. I'm then going to choose, now this is just to get a min-max line. I'm going to choose the maximum of the lowest one. So in other words, I'm going to choose the maximum of when it was the lowest reading and the minimum of when it was the highest reading. It won't make any sense to you at first, but it will once we start doing it. So I'm going to pick the maximum of that and the minimum of the highest reading. Don't worry, if you get that, well done. And some of you might, because I know Mr. Gill did this similar last time. And then I'm going to put 2 and 12 again. And I'm just going to do it the other way around now. I'm going to choose the minimum of the lowest reading, and I'm going to choose the maximum of the highest reading. All right, there we go. I'm doing the right speed now because I can see some brains here. If you've not followed any of this, here's one I did earlier. Okay, it's on the other sheet. Okay, so if you're having a bit of a freak out, that's all right. So then I'm going to select voltage, and I'm going to select current average. Now I know a load of you don't know how to do this because I know I have to teach teachers how to do this all the time. If you want to select that and that without selecting all in the middle, anybody know how to do it? Yeah, shift, no not quite. Control, shift selects all of it. Control, you have to practice doing this. It's a bit of a skill to do it. So I just do that first, then I go up to the top and then press my control key and control down. That took me, I only learned that about 2 years ago. I actually always use a mouse, and a lot of teachers still use a mouse for that. Then we've got that, then I'm going to insert And this is where I don't mind, especially if you do chemistry. Chemistry is actually quite near to physics. Biology is that little bit further away. Earth and environmental a little bit further away. Psychology a little bit further away. So just be careful what they do. Double check with me. You can't. All of those rules you can use in physics, but I don't want you spending ages because physics tries to keep the maths as simple as possible. All right. So then we do insert, and I'm going to insert a scatter graph. Don't get it joined, because you probably are told to do it in some subjects to join it. We don't like that in physics because it's artificially joining it. This is just giving us information. Your teacher might tell you something totally different about it in your other sciences because they just look at things slightly different. Okay? So I'm just going to say voltage. This is just a very boring title because I just want to get going. Voltage V against current I. And then we expect this. You can do plus to add chart elements, or you can go to design, add chart elements.
Very serious question, sir. We don't best bits today.
Wait, what?
We don't best bits today.
Best bits, if we finish in time, yes. Yeah. Alright, now, what you do is we go to axis titles, and we put the axis titles on. I'm not going to put them in yet, I'm just going to put this on very quickly. I'm just going to put, you've got to spend time doing this, I'm just going to put V here, but what should I really put? What is it?
Voltage V.
Voltage V, and I'm just going to put I here, just so we can go quick. Okay, now we've got that. Alright. Now most of you know how to add a trend line, so we'll do that in a minute and I'll show you, but I want to add a few other things first. I'm going to add, and this might be slightly different than the way that Mr. Gill did it. His way will be fine. In fact, your chemistry, any teacher's way of doing it is fine. I think this is the easiest way of doing it personally. So we go to chart elements again, or you can press at the top, add chart elements. And we go to error bars, more options. Now that will then come up here. Now with some of yours, it doesn't automatically select that side one, and it's really confusing when it does that, and we don't know why it does it. Sometimes it might say this. Click over to the bar option, and then we're going to change the vertical error bar. We're not going to have the vertical error bar what they do because their way is wrong, because this is a business, Excel's more businessy than sciencey. We're going to go to custom and specify a value. Remember, this is being recorded, so don't have a big freak out if you can't follow on, and there's also a copy. So I'm going to do the current error as my positive value, and I'm also going to do current error as my negative value, because remember the current error is divided by 2. Then that looks really weird. I don't need the side error bars, the horizontal error bars. We just don't need them. You might possibly next year need them from one topic, but for this you don't. So you click on those horizontal ones and you press delete and get rid of them. And what that's showing now is there's error, error, very small error, error, very small error. And you can see that just by looking at it. It's showing you the relative error. And it's visual, it's more interesting, isn't it? It's a lot more interesting. Then, I'll just make this a bit bigger again for you. We are going to add 2 extra lines. Now, if you look at the exemplar, and their way is good by the way, you know when I've moaned about it, it's good, it's just boring, that's all, there's nothing wrong with it. Just saying you need to make it a bit more interesting, and you should do, because some poor person had to do this. They've got a max line of best fit and a min line of best fit. I'm going to do that very slightly different. I'm going to join my lines up very slightly differently, and I'll show you why. Not the end of the world if you decide to do it differently. Okay, what we're going to do now, we're going to go to select data. This is the bit where it gets confusing. I had to watch this video when I was reminding myself probably about at least 20 times to do it perfectly. If you get it the first time, you're probably borderline genius. Well done. If you don't, you just need to practice. And I get so many people when we go into the experiment go, I want to drop physics, I don't understand it. You just need to put the effort in. You won't get things straight away. Select data. I'm then going to add. You can call it something if you want. I'll probably call it actually something this time so I don't get confused. I'm going to call it max, min, line 1. Last time I didn't call it anything, I got confused.
Max, I'm still confused.
It's alright. There'll be lots of maxes in it. So we've got this, you select max min. You select Y max min. And then you do OK. And it's giving you a couple of extra dots. This is where you'll be losing me, but I'm still going to carry on going fast because You can watch the video or you can ask me and I'll do it a bit slower with you because I want to get through this as fast as possible, because when I do it fast, everybody's watching because they get what's going on. I need to watch. Add. The next one, I'm going to call it max min. I wish I'd done this when I was practicing because it makes it easier. Max min line 2. And I'm going to select that one for max min line 2 and select the Y values for max min. The other way, if you do it the wrong way around, it just looks a bit weird. You've then got, if I zoom in, you've then got extra dots. Those dots are looking at one maximum, one minimum, and then other maximums. So instead of it being a max and a min, it crosses over. Yes?
I think you messed up your current max and current min up there. The method you used didn't give the actual max.
It doesn't, that's right. I didn't mess it up, but thank you for asking me. There are 4 different methods of doing this.
Okay.
What I did is it's called the average method. I got the average current and added the current error. And the average current minus the current error. Now another way you could do it is use max, which would have got you 0.9, wouldn't it? 0.0. And min, which would have got you that. That's just slightly different because that's doing plus or minus the error. They're both completely correct. Now the thing with statistical analysis, even though they're both completely correct, do they give you a slightly different answer? Yes, welcome to the world of statistics. So you're welcome to just use max there and min there, but I used for max average plus error and min average minus error. Both are absolutely fine because this is what we're doing with it. So what we're doing, we're trying to find those outliers. Now sometimes outliers are very, very obvious. So for example, I would not be very impressed if this was a real one and you left that one in. I'd expect a trial 4. Why? That's certainly not correct. You can't just go, and I really want to be very happy, and this might disagree with some of the other scientists, if you just pulled it out and got rid of it. I would expect to know, because in physics it's easier to do another trial. If you're a poor soul in chemistry who spent ages dissolving a nail or something, which takes forever, of course Mr. Adams is going to say just take the data out, because it would take ages to do it. How long does it take to do an experiment like this? Not long, does it? So I do 1, 2, 3, 4 trials. So you'd be actually looking at this data as you're doing the trials and go, no, something's happened there. You know, Michael might have put his finger on the current. You know, you could have just been touching it. It's that simple. It could be a reason. So do it again. If it is fluctuating, it could mean the power pack's fluctuating. Then you've got evidence, and then you can keep it in. Okay, next bit. Watch carefully. Click on it, and you can either go plus or you can go design, add chart elements. Depends. Sometimes the plus doesn't work. I don't know why. Email Microsoft. So you go to trend line. More trend line options, and we're going to do the average trend line first, the middly one, and we're going to go OK. If it doesn't say this straight away, click on the bars. We're then going to display equation on chart and display R squared. R squared may be useful. I'm then going to move it over, and underneath I'm going to put line of best fit, okay, or something equivalent, okay. Then I'm going to go again. See, good pluses work this time, go figure. Trend line, more options. I'm now going to choose max min. Now, first time I did this, I didn't give it a title, so it was really confusing. So I'm going to choose that one. I'm going to go OK. I'm then going to do display equation on the chart and display R squared. Now you might be a little bit freaked out with that one, because it makes the R squared 1. Of course the R squared's going to be 1, because how many points is that one going through? Not 1. And there's 2. Look at the orange. How many orange points are there? 2. I chose 2 points using that data from before. So it's going through. Now if it's only going through 2 points, it's always going to go through those points, isn't it? So we don't need the R squared equals 1. You can leave it if you want. But this will be max, min, line, 1. If you're doing a max or min, you call it max or min. Next one. You'll then go plus. Trend line. More options. Which one we're going to choose this time? Max min, line 2. So we've got this one. It sometimes, and I'm glad it did this on me, it sometimes won't draw it straight away, just because it slightly hates you, like all computers do sometimes. So then you go, add chart elements, more trend line options again, and again it doesn't want to work. See, it's just having a bit of a funny, so we don't worry about it, we just click off it, click back on. It's good it's done this on me. It normally works perfectly for me, and then people have a big panic when it doesn't work. More trend line options, max min line again, And there we go, it worked this time. See, I've got to click over, not a big deal. I'm going to display the equation. I'm not going to bother displaying r squared because it's just going to give me an r squared of 1 again, because how many points is it going through? 2. I'm then going to do max min line 2. And if you see, my lines are a bit different because the person who did the other chart, their one was a max line and a min line. This one actually crosses over. See, I'm crossing under and crossing over. Now, the reason why I do that, you don't have to, is if you notice here, there and there, what do you notice about the error? What do you notice about the error? Does it cut through it? Yeah, and it goes beyond it. Now, this is important to realise. I'm not trying to worry you here, and this is where I can help you every single time. But they put it a better way than me, so I'm just going to get this up and just read it from the University of Southampton. Cool. So, we're going to do max min lines to a graph, and it says here, additional note, if x and y error bars are shown on the data, then you should assume that for each data point these error bars describe a box. In this case, the max min lines must pass through and touch every box to be valid. Now what that means, it's got to pass through, because if it doesn't pass through, that means you've got a massive anomaly in your data, and it means to get rid of it. And you will, you will spot that. Because if you're not sure about it, what can you do when you've done your experiment? Check with me. Yeah. Okay. So, what I've done is I've put some research databases for you for later. I've also put the science inventory because you're all asking me what kind of equipment we've got, but you can just ask me. Now, how to write a student's experiment. Only have to look at the highlighted bits to save you having to spend forever on it, because I'm very nice. Okay, so I spent ages reading this to make it easy for you. It was very long. It tells you what the criteria is. You don't really need that yet. You can do that after you're finished. It tells you how to step it out step by step. You're going to be doing that in any case. See all the yellow stuff? That's the bits that are important.
What page is this on?
This is called student experiment. It's the one right at the bottom, how to write a student experiment. Okay, next one. They give you a couple of examples for ideas for your ones, but I would just use one. Use an experiment like Lockham was talking about. Use one that you've done before, or one that's simple and just modify. And I'm going to give you some examples in a minute. This is one they've done. I might as well do the one they've done, actually, as well. So we did a very simple one on just basically finding out voltage and current, didn't we? That was the simple one. People listening, thank you. You could then modify it by investigating how temperature affects the voltage or currents. Now, it doesn't have to be a diode, it could just be a resistor, because some of you are talking about you like heating things up and cooling things down. You could do that. You could measure the intensity of light produced from a diode. You could do that if you want, but I think that was far too hard. I've given you some examples over here. So these are just some random ones I got, and I'm going to show you how we decide if they're good or bad. So I'm just going to read a couple, but then I'm going to give you the skills to decide if they're good or bad, because I noticed with the other scientists, you didn't realise what was a good one and what was a bad one. So we'll just do the top one. What is the relationship between the cross-sectional area of a wire and resistance in a series circuit when providing different voltage levels that change with constant voltage on each trial? Now let's not decide whether it's good or bad yet. What we do is this is a cool, I love things like this, a flow chart. This is to decide whether my question's good enough. And it will be good enough, but whether it's worded correctly. So firstly, does the question relate to the appropriate topic in the syllabus? Let's just grab that one and pull it by the side of it to see, because that's how you learn with something. So we're just going to grab this one, we're going to copy it, and we're going to stick it over here. So we're going to see with this one. So we're just going to copy it and move it over. So let's have a look at it. So let's see. People are talking, which is a shame because you're not going to understand this. It's quite ironic when somebody's saying, I don't understand this, but by talking, you're not going to listen and understand it. So, firstly, does the question relate to an appropriate topic in the syllabus? Yes or no?
Yes.
Yes. Does the question relate to a class practical? Is it possible to investigate?
Yes.
Yes. Specificity. There. Are the independent variables clearly stated?
Yes.
Yes, they are. We can make it probably a little bit clearer. That's good. Are the variables worded so that measurement can be achieved? Now, what I mean with that, I would probably, instead of the word change, I'd rather increase or decrease, tell you the truth. I know your chemistry teacher says similar things, doesn't she? And he. I think it makes it easier. Why not just say what you're going to do? Because change is very wishy-washy, yeah? So it's fine, but I would say maybe a bit more clearly and explicitly. Explicitly means you're being clear and saying what exactly is going to happen. Answerability, which is a word, okay? It's one of those very ones that you've probably never used before, except in science. Can the question be directly answered, verified, or falsified? You might not know that for this one. Yes, it can. You need to do a bit of research. Achievability. This is the big one.